Hey guys, I just want to go over some of the common mistakes that I'm still seeing when we're taking derivatives. So the first one I want to start with is just derivatives of trig functions. And so the two main ones I want to look at are the derivative of secant x and derivative of cosecant x. And so the derivative of secant, right, is secant x tangent x, and derivative of cosecant is negative cosecant x cotangent x. All right, and the mistake that I'm seeing is that students are forgetting to include the x on these first terms, or whatever the inside of my function is, right? So whatever that angle is. And so what I would be seeing is, she's red, right? I would be seeing secant tangent x, and these are not the same thing. Or I would be seeing maybe negative cotangent cosecant x, and again, these are not the same thing. This would be saying that I'm going to take the cotangent of whatever this value is, okay? And so if we just did a quick example of it, if I wanted to take d dx of secant of 2x, the derivative would be, well, it's going to be secant x tangent x, and so whatever's on the inside will go in those spots. So we'll have secant 2x times tangent 2x, and then times the derivative of the inside, which is just a 2. And so the derivative here is 2 secant 2x tangent 2x, right? Not, again, what I would have seen would be 2 secant tangent 2x, and this is a no, all right? It is not that. We need to include that same angle inside the secant, inside the tangent. All right, and so that's the first mistake that I've been seeing with some of your work. The second one I want to go over is differentiating implicitly. And so if we had xy equals 2x minus y, and I want to find dy dx. So we're going to differentiate this implicitly, and what I was seeing is students forgetting to use the product rule whenever we have two terms together. And so if we look here, I'm going to have to apply the product rule here with x and y. I won't need to apply it here or here. And so if I wanted to take the derivative, I'm going to take the first times the derivative of y, and so derivative of y is just dy dx plus the derivative of the first, which is just 1, times the second, which is just y. And so that's the left-hand side using the product rule. I can't forget to use the product rule. Equals, well, on this side I get a 2 when I take the derivative of 2x with respect to x, and the derivative of negative y is negative dy dx. And so now I'm going to group together my dy dx's, and so x dy dx minus dy dx. Oh, I don't know why I put a 2 there. Eraser. So dy dx equals 2 minus y. And so if you factor out a 1 and then or a dy dx and divide, we'll get 2 minus y over x minus 1. All right, and so that's the derivative there. Another quick example with that would be something like cosine of x plus y equals, let's see, let's do xy. And so here, again, we're going to have to use the chain rule. And so inside here we would get negative sine, copy of my inside, times the derivative of the inside. So on the inside here, I have to group those together, so I need a set of parentheses. I was seeing a lot of students forget those parentheses, and so the derivative of x is 1 plus the derivative of y with respect to x is dy dx. On this side, again, we're going to have to use that product rule, and so we'll get x times dy dx plus the derivative of x times y, and so just y. And so here, right, if we want to simplify and find dy dx, we're going to have to distribute this to both terms, and so we'll get negative sine x plus y minus dy dx of sine x plus y, and that's going to equal x dy dx plus y. And so parentheses matter. I was seeing a lot of students forget that when you had problems like this here. Okay, so again, those are just two of the common mistakes that I was seeing, and hope that helps.